All right, so I'm Abiba. I live in Dayton. So this is like my first Ohio DevFest. It's pretty cool, pretty rad. Um, Today, going over Reactive X, reactive programming, really fundamental stuff since, it took me a really long time to get my head around it all. So I figure I'll help some people get their heads around it too. Okay, so anyone here born after like 99 or 2000? Okay, cool. So we've all grown up with like websites like this. Like we've all seen these. And like this one and this one, this one. Got some more. My favorite one is this one, because Internet Explorer is really evil. But we've, is this full screen? Okay, I don't know why it's not full screen, but. So we've all seen websites like this, and they were clunky, they were old, they were ugly. I think worst of all, they didn't really have any interactivity. You just followed some links, you got some information, and then you left. It is pretty basic, the internet back then, mostly because of hardware stuff. So, as we kind of moved ahead in hardware, we got a little less ugly web. Anyone remember Friendster? No, I'm the only one maybe. Yeah, okay. And MySpace, I'm sure everyone remembers MySpace. And we got Google, so things really picked up from where they left off, and we got a lot more interactivity. Things became less ugly. We didn't use tables for styling, which I guess was like a super old thing. I don't remember it, but all my teachers remembered it. But again, hardware moved up, so did the tech that goes with it. And now we're here. So we got IoT now, big thing, big buzzword. SPA, single page applications. Responsive apps for mobile. So one thing that these three all have in common is that they're all kind of based on speed and finesse and being able to handle rapid changes that the user is going to give it, or even like a server. So that's kind of where reactive programming comes in. It's kind of able to handle all that. So today, I'm talking about my journey with reactive programming and RxJS, and then give you a light intro into reactive programming as a whole, and then we'll go over RxJS, the fundamentals, and then some cool stuff that you can do with it. So, my journey. I've been coding since like high school. I was always a computer nerd. I was playing StarCraft like when I was 2. I've got like a picture of me sitting on the computer like that tall. So I've always been messing with computers. It was pretty funny. I was talking to another speaker last night, and I was telling him about in middle school, my parents wanted to check my grades, and it was all online. So like, I didn't have the grades that they wanted to see. So I like went into the developer console and like messed with the grades so that it would show all A's, and they're like, wow. And yeah. And the next week I got my paper report card, and I was very grounded. But RxJS, so most people come first contact with it with Angular, because Angular's HTTP client uses it. So that's where I came into it. And I'm sitting here exactly like this. What is an observable? What does any of this mean? Why can't I just make the call and get my data? Then I learned in the Angular docs exactly what I needed to know just to get by. Started using that for a little while, and then supervisor comes up to me. He's like, you need to put an operator on this observable. I'm like, what's an operator? So I go back to where I was before, start from the beginning. And then I was like, you know what, forget it. I'm going to go learn everything so that I can't get confused anymore. Boom. My desire to know definitely intensified. So if you guys come out of here like super confused, that's good, because that's exactly, I think, how you got to start it. So don't feel bad. I won't feel bad. So reactive programming. What is it? What we're going to go over? It's a part of event-driven programming. We'll go over imperative versus declarative, and then imperative versus reactive. This is all higher level stuff, so a little boring, just stick with me. So event-driven programming is basically programming based on events from the user, from a server response, a thread completion, user input, or computer input. Reactive is a part of that handles with data streams mostly. So here's user input. I don't know why Chrome doesn't let you start, but yeah. Okay, so reactive versus imperative. Kind of a higher level example. So let's say we have an equation A equals B plus C. And we want to evaluate it for A. So next values, 3 and 2. For our reactive programming on one side, A is equal to 5, imperative, A is equal to 5. Boom, same thing, obviously. But let's say later on in the program, C changes. So C is 5. Reactive listens to it. It's like, okay, C is 5, let me evaluate this equation again. A is equal to 8. Imperative is like, I don't care. Until you tell me to evaluate the equation again, I'm not going to. So A is still equal to 5. That's like the whole concept of data streams, handling data streams. So here's an actual code. Okay, cool. So on the left hand, imperative, or right hand, sorry, I don't know why it's flipped. We've got imperative programming. Simple function, takes in 2 numbers, adds it. Should probably return A, but it doesn't. So obviously you can see you call add once, it's going to add it. B and C change, it doesn't matter. Over on your guys' right-hand side, we've got the reactive. This isn't going to make much sense to you right now, but just know it's listening for B and C passed in. Whenever one of those changes, it's going to run whatever's in that block. So A is going to be whatever B and C is equal to when it's changed. Okay, so imperative versus declarative. Think of imperative as your grandma that cares about you, and just, so let's use the example, your grandma wants cookies, so she tells you how to make it. She tells you what temperature to bake it at, where to get your ingredients, what kind of raisins, because old people like raisins, how to mix it, how fast to mix it. And declarative is like your best friend, who says pretty much, I don't care how you get these cookies, just get me cookies. I don't care if you go to Kroger or you make them, just kind of get them to me. So here's kind of a code example. Up at the top, we've got HTML. It's got a button and a paragraph. Disregard the middle part. But below you see the JavaScript. JavaScript's the important part. We're grabbing the element, on click, we're going to grab the display, check and make sure it's a paragraph element, and then change the inner HTML to get the new dad joke. Dad, can you put my shoes on? I don't think they'll fit me. That's a pretty good one, I think. And then we have declarative. Declarative, this is written in Angular. I don't know if we have people who are Angular people, but so the click is an Angular click. On that click, you change the dad joke, calls dad joke. Dad joke changes the dad joke variable, and then P displays it. So the difference between these two is, in here, we're touching the DOM. We're messing with everything. We're checking everything. We're making sure that it's a paragraph, and then we're actually putting it in ourselves. Whereas with the declarative, we just tell Angular to handle it. We don't touch it. We tell Angular what we want rather than how we want it. And I think that's an important concept to kind of get your head around with, especially functional programming. So why is any of this important? Reactive programming, whatever. So we have single page applications. Can't be slow. I mean, personally, I know when I see a application and it's supposed to be single page and I click another thing and it loads, I don't count that as a single page application if it takes forever to load. It's not responsive to myself. And you got to handle data changes during a single user session, which can be clunky to do without frameworks, so reactive programming is perfect for it. We've got WebSockets, or WebSocket. It's a protocol that basically allows two-way communication between different nodes. So like, let's say you think of like a chatting app. So you can push and pull messages to and from people. which is important because you have to constantly be listening for different data changes and stuff. Finally, we've got IoT. I think IoT is rad. I don't know if you guys know of Losant. It's an IoT startup here in Cincinnati. You should definitely check them out. It's pretty dope. They let you like build stuff like in a GUI. But for those who don't know, it's the concept that everything should be connected, all of our devices, all on the internet. And it deals with constant data streams. So smart fridges, Alexa, you kind of have to be able to build dashboards for it, which actually listens for that data that you're getting. So it's super important that you're reactive. There's a smart egg carton, which is, I don't know why you would need that. You drop like $40 on that just to refill eggs, I guess. But obviously you can make a quick app that tells you, hey, get eggs with that, if you're super bougie. Okay, so ReactiveX as a whole, it's a big project that deals with reactive programming for a whole bunch of languages they have. They've got Java, they've got Python, they've got a few others that I really don't care about, but JavaScript's the only thing I care about, so boom. JavaScript's already pretty reactive, so it's kind of like a match made in heaven, really lightweight. So there's three fundamental parts to RxJS. You got observables, you've got observers, and then you've got subscribers. This makes no sense to anyone until you actually see it. It took me like 4 or 5 months to actually figure out what an observable exactly is. Hopefully it'll take a lot less time. So think of the word observable. So it means that you can watch something, you're seeing it, a specific object. Think of scientists, so when scientists are observing, I took geology, I love geology. If I'm looking at a rock, and that rock changes in my hand, which hopefully it doesn't unless I'm like magical, but I'm gonna write it down, and I'm gonna observe the different changes it has. So the One Ring is observable by Sauron. So he's constantly watching it, and he's like, where is this ring? I need to grab it. So think of it as a function that can return multiple values over time. It doesn't actually do anything, it just represents values in any moment in time. It's a very abstract concept to kind of get a hold of, but think of it as representing you watching something. So here's a code example. We have observable, uses the Rx type observable.create. The observer.next tells the observer to emit a value. So in February, March, November, April, May, that's getting emitted, but nothing's listening to it. So nothing's happening. So we need to find a way how we can grab that data that's being emitted. Think of observables as kind of just a stream of water, just going through. Observables on their own don't do anything. You just kind of let that data flow. So observers. The Dark Lord Sauron is an observer. Also, he's like a big eye, so it's like perfect. But it's basically just a collection of functions, and you're telling the computer, you're defining what to do once you get values emitted. So see, we've got the next function. That defines when a new value is emitted. So usually after values emitted, you'll get another one, so you have to constantly handle it. So right now we're just printing out the dad joke. Then there's an error function, which defines what to do when there's an error, obviously. And after that, once you get an error, you don't get any more functions. You don't any more values. It just stops. You have to resubscribe. And then you have complete, which is like an error, but there's no error. So once you get a complete from your observable, it just stops emitting completely. Pretty intuitive. Think of observers as kind of a turbine on a dam. It doesn't do anything as is, but it could once you put it in. So in order to do something with observers, use what's called subscriptions. Just throw that bad boy in the .subscribe on your observable, and it runs asynchronously. It's going to constantly listen, and then especially what you tell it to do, it's going to do. Pretty simple. One thing, don't get confused between observables and observers. They sound almost like identical. Just make sure you remember observers do the stuff, observable is the stuff. So put it all together, we've got a fully functioning dam where we're catching that data, doing stuff with it, letting it flow out to wherever it needs to go. So now getting to the fun part of RxJS, you can do really cool stuff with your observables. So operator, I've never actually heard this song before, which is kind of bad, but operator, I actually put that in. Operators, you can put operators on observables which do exactly what you think operate on observables. So what are they? Methods on the observable type. They'll never modify the observable that you call it on, which is parallel into functional programming where you have pure functions which don't modify your state, they just give you a new one. And this helps you kind of keep consistency and prevents you from getting weird errors that you don't know. And it's there's so many operators on observables. I'm just going to cover some of the cool ones that I like, some of the commonly used ones. There's some that I don't know why they exist, but I guess there's a reason. So there's two types. You've got an instance operator, you've got a static operator. So your instance operator is called on your actual observable object. And this is used to change data from that observable. So whenever an event is emitted, or a value is emitted, you can tell it what to do with that value, and then it returns a new observable with the value that you've edited into, which you can subscribe to. For example, you have the pipe.concat that puts in two observables, mashes it into one, and you subscribe to that one. Then you have static. Static is called on the actual type observable. Excuse me. So here we have observable.create. That's not an actual observable, that's the type that we're grabbing in, the class. So that basically creates an observer from scratch. So static operators are usually used on just creating a brand new observable, either from an existing one or from different stuff, which we'll get into. So .map, if you use JavaScript, the newest ES6, you probably use .map function. So what it does is it takes the value that you have, you tell it what to do, it spits out that other value. So here we've got a score, and we're returning the joke, which we're getting to, X, adding joke score plus the actual score, and then sending that back out. It's almost like a factory, you're just kind of changing stuff up. This one's really useful, especially when you're handling kind of server responses and you want to map that data to a different one as you're getting it. So, I mean, this one I think is the most widely used. Next we have the group by. So group by takes an object's property. So you're getting a complex object, not just primitive type, and then you're getting an array of those grouped together, if that makes sense. So if you look at the example, we've got score of 4, it's grouping by x.score. So you've got the score and we've got the joke. And it's putting in arrays, putting the jokes with the same score in the same arrays. So with this, you can just kind of imagine if you have a big clunky object, you want to group it by users, you want to group it by, you're filtering a table, you want to group by in a table. You can definitely use this one for that. So here's the merge. This takes two observables, mashes them together into like a Frankenstein observable, and then anytime either of those is emitted, that observable is gonna emit one. So if you need to make multiple API calls, for example, you're just gonna throw them in together, and that way you can handle them all as a single call. Here's one from promise. You can turn your promise into an observable. Pretty self-explanatory. Promises, they save us from callback hell. Observables are saving us from promise hell. So I think it's definitely the next step into promises. And here's some stuff that I have. I'm publishing these slides, so you'll be able to have all this stuff. If you Google RxJS, it comes up with the the manual. There's a website called Learn RxJS. It's higher level, but I definitely check it out. That's all I got. So questions or a demo? What do you guys think? I'll take questions because, I mean, if you got questions. No? We can do a demo. Anyone here Angular? Couple? 3? 4? Oh man, okay. How many here are React? Less React than Angular, that's wild. Oh man. Okay.
Do you leverage JSX or Reactive JS in React
Oh yeah.
as well?
Yeah. So there's actually, I was talking to a couple speakers. They're using it in Java and Kotlin. So you can definitely throw that in there. It just comes with Angular by default because Angular likes it, I suppose. But yeah, it's in React. You can just import it, npm install RxJS. So let's go over. Show you guys my source code for everything. Okay, so let's get rid of this. Let's say anytime a user wants to click a button, I mean, it'll be pretty simple. Let's just do anytime a user clicks a button, we get a new dad joke. So we'll create an array of jokes. And there's actually a website I got all of my dad jokes from. It's called Nice One Dad. It's pretty funny. Okay, so let's throw that one in. And we'll get one more. Hopefully it's not as long. I think we're gonna make a dad joke API that anyone can just call. This is the classic. This one's the classic. Dad, I'm hungry. Hi, hungry, I'm dad. No. Okay. Why did this bug? Come on. Here we go. What's going on? What did I do? Weird. Okay. So let's create an observable. Observable dot create. Oops. This is not rehearsed, by the way. What are you doing? There we go. So create an observable. And then we're going to emit maybe not. did this wrong. This should just be observable, right? There we go. So let's just emit jokes math.random. Okay, let's go over here. And then, so whenever it emits, we'll just get all three. Cool. All right. So now we can subscribe to it. So we do, gotta name this, joke observable. Now we're gonna do joke observable dot subscribe. So this is async. So ng on init, for those who don't know, this is ran when the component for Angular is emitted or starts. So once it's rendered, this is run. The subscribe, you pretty much put all of your subscribes in there. So during the life of the component, that'll constantly run. So you can define your functions in here. So we just do, the first one's our next function. And then the one after that's our error function. And then after that, we've got our complete function. The complete function's completely optional. You don't have to handle that. There's not a lot of cases you would handle it. But let's go up here, create a new variable called joke. This is TypeScript, so we'll use a string. So anytime we get a new value, let's just set joke equal to that value. This.joke. Cool. In the error, we can just console.log error. Oops. And then in here, Angular, let's just put a p tag in. Joke. Cool. So let's do this. It's going to run instantly, so let me change it real quick. Let's just concat. So it'll be just 3 long jokes. Angular takes forever, so while that's loading, I'm going to go look at some more jokes. I've actually used that one too many times, so maybe one day it'll load. Time's 11:30. I don't know about you guys, but I'm pretty hungry. Well, if it was going to load, we would see the 3 jokes. Oh, there we go. Let's go build. So we're going to end up seeing all 3 of those in or well, 2 of those, because we're only emitting 2 random ones, and they're going to be concated together because that's kind of what we're doing. The joke is global, so let's see. Awesome. What is going on here?
Math random is going to give you a decimal between 0 and 1, so you need a
Oh.
threshold.
Yeah, you're right. Let me, why is this router out? I don't need this. That's a good point. I forgot about that.
I just put 0 and 1 in there for sake of example, instead of looking for them.
Yes. Boom, look at that. I don't know why, oh, it's undefined because we're starting from, joke starts off as undefined, so JavaScript's cool because it'll handle that, so. Yeah, that's the impromptu demo, I guess. So I definitely recommend checking out RxJS. I mean, are you gonna need it for every project? Definitely not. Are you gonna need reactive programming for every project? What's up?
Do you have any like specific use cases where introducing Reactive.js makes a lot of sense? Like promise hell.
Yeah, so I'll give you an example. In my last job, I was building a single page app, and we had one page that was a table that had a whole bunch of stuff. And then we had another one that you would click on, like an add new, and then that came up with a form. And once you submitted the form, we had to figure out how to listen to that and then grab all of the new stuff that's supposed to be in the table. So I put a observable and a subscriber. So when I submitted the form, I would do the .next with whatever, and then in the table, I'd put on the ng init to listen to that observable. So whenever they got called, we'd hit the API again and pull all of our stuff, if that makes sense. That's one example. Another one is, I mean, you use observables in place of promises. So anywhere you would use a promise, an observable's better suited for that. Because you can do more stuff with an observable, you can unsubscribe from an observable. So when you're done listening to something, you just unsubscribe, you're done. Another example would be, I mean, all Angular stuff, honestly. SPAs is a good one. If you're building a mobile app, a web app that's suited to be mobile, instead of doing viewport stuff, you can do observables. I did that. It's a little ugly, but you can handle it more complex, I think. Any other questions? I'm ready for lunch, so if you guys don't have anything, we can go get food. Awesome. Thank you guys. Appreciate it.